Hey everyone, I just realized I don't have the lab in your module, so I'm getting that right quick and I'll post it on Canvas and then I'll get right back with you. Let me find it real quick. Hmm. All right, so the lab is not in the course. I forgot it was part of our manual last semester. That's why I didn't have it in here. I'm going to go to my other computer and transfer it real quick. Hopefully everybody's already watched their video. Uh, the three videos that I sent you via email. So make sure y'all watch those. I'll be right back in just a second. I'm just going to go to another room to another computer and post something to here. I'll be right back. You can take 5 minutes. In this lab, we're actually going to basically do a Geiger counter uh, experiment to show half-life. And we're also going to show you that half-life and exponential decay is, not something necessarily just related to nuclear energy or stuff like that. We're going to show it to you in terms of a big box packed full of dice, basically. So we've got these wooden blocks. They got the marks on them. You saw the video already. They've got these marks on them, and we shake up this big box full of these blocks, and you then pick up all the ones that have the red mark up, count those, and then you do it again, count them, do it again, count them. What you'll see is the number that goes down, the number of blocks present goes down, the number that actually sort of decay, if you will, the red ones, decreases as well in exponential growth. So let me share my screen and we'll open up the actual lab. So I think it's here, should be there. So I'm going to scroll down here. I'm going to minimize this, scroll down here and look to our lab, which is not there. No wonder I went to the wrong class. Doop-a-doo. Let me see if it's in this one. Nope, it's got to be that. I got to go to the dashboard. So that was the class that we did the lab in last. So I thought that would be where the document was, but then I remembered that was a class that started off face-to-face, and they actually had the manual already. So that's why I wasn't able to find it there. And then my computer just took forever to come on. It's still over there, that little wheel going. So that's aggravating. Anyways, here we are, week 5. It's this lab right here, sequence 2, lab 11, which I'll change that to probably lab 10 because I think that's what we're on now. And if you remember when you watch those videos, I actually slowly filmed the data table so you can actually pause it and then copy the data down here. So basically we're going to use a isotope generator that contains a 370 kilobecquerel cesium-137 source. So basically these are things that are put out by Oak Ridge National Laboratory for educational purposes. It's basically this cylindrical thing like this that basically you squirt water through. The water actually has some radioactive isotopes in it, but some isotopes in it. So you squirt the water through it, and then the water comes out after being exposed to cesium-137. It comes out with barium, which is what the isotope inside the water was. The barium water comes out now with some radioactive isotopes of barium, barium-137, and that has a half-life of about 2.552 minutes. So when I squirt it through slowly so it doesn't squirt all out, it basically is forced to expose itself to the cesium-137, which has been used in in hospitals for radiation treatment and various other things. But basically, it's a beta emitter, so that beta emitter actually induces some of the barium in the water to become barium-137. The barium-137s emits gamma rays, and they're going to basically decay to the stable state. The gamma decay has a half-life of only, like I said, 2.552 minutes. It's milked through the isotope generator, and then after milking it, you sit it in front of a Geiger counter for 15 to 20 minutes, and you do the activity counts. So the solution decays so rapidly that after 30 minutes is lower than 1 in 1,000 its initial activity, so it can be safely emptied into the standard drain. So yeah, that water has barium in it. Barium's not a bad problem. After 30 minutes, it's no longer got the radioactive isotope of barium, so you're actually allowed to throw it right in the sink. So with that, you end up getting an N that's equal to N0 times e to the negative lambda t. You're going to actually take this BNC connection at the back of the Geiger counter, connect the Geiger counter tube to it using the nucleus counter. That's the Geiger counter that we use. You turn the power button on, turn on the counter, set the toggle switch at the top to preset the time, and rotate the hand dial to 0.5 minutes. So in other words, every 30 seconds, it's going to give you a count, and you're going to record that. So remove any radioactive sources from the vicinity of the counter tube, press the count button. After 30 seconds, the counter will automatically stop, giving you the background count. This is the count of cosmic rays, natural radioactivity, etc. So initially, we do it without the radioactive barium at all. We're just putting the Geiger counter out in the room at the same location that we're going to be doing the barium. And we take several 30-second counts, we record them, take the average, and that lets us realize, okay, well, this particular room at this particular time has this many radioactive accounts, if you will, or radioactive counts, not accounts, per minute or whatever. So we can subtract that out of the signal when we actually put the radioactive stuff in it. So we'll put these 1, 2, 3, 4, 5 there and count the average. You probably already seen those numbers in the video. So you want to go back, turn to that part of the video, and then put these numbers in and then take their average. Any questions on that? Okay. So next you're going to reset the counter. And obviously you wouldn't want that. We actually did this the first time. It was kind of screwed up. We actually left the source of the cesium-137, that cesium-137 source, we left it right next to the Geiger counter initially. And I looked at it, I'm like, these are some really high counts I'm getting from the Geiger counter. And I realized, yeah, the cesium source is right next to it. So in the lab, you did need to make sure that there's no radioactive sources nearby other than nature. But anyways, you reset the counter, you prepare the barium solution by squirting it through the milking device, the elution process, and then it tells you how to do the elution process. The main thing is you're just squirting it through this little thing. Water drips out the bottom. The water that drips out the bottom is the now radioactive form of barium-137. So it's really not that harmful, one, because its half-life is so short, and you're not really supposed to be getting it on you anyways. So you're supposed to immediately place the container with the barium-137 solution under the Geiger tube. You will then simultaneously press the count button and start your stopwatch. The counter will automatically stop after 30 seconds. You're going to record the count and then reset the counter. Do not stop the stopwatch. When the stopwatch arrives at 1 minute, you will start the counter again. Then at 1:30, you'll do it again, so on and so forth. To keep doing that. So at each of these time intervals, you're going to have basically a count at 1 minute, 2 minutes, 3 minutes, 4 minutes, so on and so forth. So that gives you counts. Again, that data is in the actual video, so you have to fill in this table from the video. Then you're going to do the half-life simulation with the 400 wooden blocks. In that case, you're going to close the top, shake vigorously, randomize blocks. I didn't even close the top, you'll see on the video. and you shake it, and then you remove every wooden block whose X is facing up. Those are supposed to be the decayed nuclei. Record the number of blocks you remove. You put that there. You shake it again, record the number of blocks you remove, put it there, shake it again, record. Again, this data is on the actual video, so you fill that in. Now you're going to take and subtract the average background. So you're going to take those counts that you had up here, and you subtract that average from it and put it here. Do the same thing for t equals 1, same thing for t equals 2, same thing for t equals 3, so on and so forth. Now, after you do that, you're going to then plot counts versus time on a graph using the Excel scatter plot with no connecting lines. You'll place the time expressed in minutes in column A, the counts minus the background in column B. You could make two columns if you wanted to in your Excel spreadsheet, and one being the counts and one being the average count, and subtract it that way, but you might as well just do it by hand. But make one column of the counts and one column of the minutes. And then you make a graph by adding a trend line, then choose the exponential trend line, add the equation, the R squared value for the graph, print a copy of your graph. By that, I just mean take a screenshot of it and include it in your lab. So if you notice in your lab one, the ones that you saw were graded, basically I'm asking you to have your data and your analysis all in the same spot. So right now we're doing the cesium barium mini generator. So you'd have all this data right here. You have this equation here. What I'm saying is in this Word document right here, or maybe even right before you do half-life simulation, put in a snapshot of the data you use as well as a snapshot of the graph, and then start this part, the analysis here, okay? So that's how I want your labs turned in. I want the data right near the analysis or the procedure. Sometimes it just has a procedure. That's why I said procedure or analysis. But generally, I want them in the analysis section. So you'll have your raw data here, and then you'll have, it helps me if you put in your data from the Excel spreadsheet, because then I can find typos. But that's not as critical as having the proper data in here as well. So once you graph it, I'd want all that here. And you can point the half-life, determine what that's supposed to be, compare that to 2.55 minutes and all that stuff. Then you do the half-life simulation. So we're not doing the whole group thing because everybody is one group, so you can ignore that part. But you're going to basically then find out what the decay constant is using the same sort of stuff we did for the other one, find out what the half-life is, find out what R squared is. And again, you're going to skip the stuff for the group. It turns out the reason why we did the group at all is it turns out you will probably get good results, but when you compare the group average, you'll get a phenomenal results. In other words, it'll tell you exactly how many cubes there were to begin with and stuff like that. So that's all you got to do with this lab. Does anyone have any questions? All right, I'm going to stop sharing the screen then. And I'm going to put everyone in their appropriate breakout rooms. And this one, like I said, I think y'all really will benefit from working with each other on it. Y'all are free to go as soon as you feel like you've got the lab done well enough to understand. I'm going to be here in case you have any questions, but I'll be working on other stuff. So my camera will be off, but you can talk to me at any time. Anyways, let's do the breakout rooms. We'll do breakout rooms. I'll do 6. In room 1 is Janice and Jayla and Marianne and Shruti. And breakout room 2 is Bryson, Kelter, Charles, and David. And breakout room 3 is Elizabeth J, Kelsey, Owen, and Taylor. And breakout room 4 is Davis, who isn't here, but Akua, who is here, Elizabeth S., who's here, and Isaiah, who's here. And then breakout room 5, we've got Najee, OG, Philip, and Nyla. Najee, OG's not here, Philip, and Nyla. And then breakout room 6, we got Kyle, Sarah, Rihanna, JC, which JC, Riley, and Sarah is all that's there. So it looks like OG wasn't here. Looks like Davis wasn't here. And we had JC, Riley, and Sarah. So Rihanna's not here. And Kyle's not here. All right. You've been sent invitations to your room.
Professor Younger?
Yes.
Real quick, I just had a question about the last lab. That was one from Monday.
Uh-huh.
So I'm on like part C of the analysis where I'm just trying to calculate the theoretical. And I'm getting like a numbers very small and like way smaller and different than like the V cap, which is what we're supposed to be. And like I'm just not sure how I'm getting that because I'm following the formula that was provided like exactly. So I'm just not sure why my it's so much smaller.
I'm trying to see, is there a way you can share your screen with me?
Using the wrong velocity. Show like my desktop too. Let me see. It said the host disabled it. It says host disabled attendee screen sharing.
Yeah, I'm trying to figure out how I can do that. Let's see here. I had it before and I thought it was right here under the more, but it's not doing that now. Let's do advanced sharing options. There you go. Okay, you should be able to now.
Okay. Okay, I think I did it. Did it work?
Yes, I'm seeing it. I'm seeing your desktop. Yeah.
So
gotcha.
these are much smaller than like these values. And so clearly the orange, they're not matching up with the like line or anything on either of these.
Okay, I think that's because you're using Q and micro. Let me
For
see.
this.
Yeah, where's your Theo formula? Can you click on that formula for me? Okay, I say B2. So what is B2? Show me that number right quick if you don't mind. Oh, it's that 67176.
6.7. Mm-hmm.
Okay,
and then it should be 1 minus.
I think that's supposed to be 8 flat.
Like, am I supposed to
click on your V?
I thought the 8 volts was the V bat.
Yeah, it's supposed to be the V of the battery. So that B $2 should be associated somewhere down here in the bottom, like in call a row 21 or something. You should put V battery as 8.00, and that should be in place of the B $2. So that's one problem we have.
Okay, so for all of these, I should be using 8.
Yes, for that where it says $B $2, that should be 8.
I think increasing that would still make.
Yeah, that's not going to make much of a difference, but I see the other problem too, so don't worry.
I actually just erased it.
Yeah, do that for a
Yeah, it's
trial
still
just to see.
very small. Do I drag it down?
Yeah, go ahead and drag them down. Now we're almost finished, but the problem is you've got down there in the bottom, that should be R times C. So you've got just R there, I think, and you, not only that, you don't have it in the right units. You've got 20 in the denominator of that exponent. And that should really be 20 times 10 to the third times, if I remember correctly, we used 1 microfarad, so that'd be 1 times 10 to the negative 6.
Yes.
So that's what should be in that slot for the 20, not just plain 20.
So it should be 0.02.
Yeah, that sounds about right. Let me just double check that. I'll do the math on it.
Okay, I'm still only getting like 1 point something.
So 20, it was 20 kilo ohms what we used for the resistor, right? And 1 microfarad for the capacitor?
Yes.
Yeah, so it should have been
Yes.
0.02. And then A2, oh, okay, there's a problem too. So the dollar sign is only supposed to be used to say, hey, I repeatedly want to go to A and 2. You're wanting to repeatedly go to A2, then A3, then A4, so you can take out both of those dollar signs.
Oh, okay.
So that top one should be A2, then the next one should be A3, and the next one, because when you copy it down, it'll automatically fill that in.
Sorry, I have like no internet. Is that okay that I'm still getting 1.1 for my velocity instead of 8?
No, we're gonna see what's going on with
Which is
that.
actual...
Yeah. Go ahead and change the dollar sign, get rid of that. I want to make sure, I want to see what that's
Sorry, it
going to
won't let me
become.
change it because I have like...
I think I found the other problem. Let's see. Is your computer froze up or something? I'm just wondering why you hadn't changed the dollar signs yet. Oh, looks like we lost her.
Hey, sorry, I got disconnected earlier. Sorry, I cannot hear you.
Duh, I'm muted. I said, did you change that $A, $2 on your spreadsheet?
Yes, do you want me to share my screen again?
Yeah, if you don't mind.
Okay.
There's another error too that I realized.
Okay. Yeah, my connection just completely went out.
Yeah, I'm sitting here talking to you. I was like, man, did your computer freeze? Did your computer freeze? And then you disappeared. So when I look at your V capacitor,
Mm-hmm.
I think you took the wrong V's, because
Okay,
the
hang on.
V should go up in time, not down in time.
So can you see the screen now?
Yes.
Okay, so yeah, let me see. This was for the very last one, the 0.016. So what is the V cap then?
See where it says 7.997? That's the V for the capacitor.
Okay, then I think that's what I messed up. I used that for what did I use that for? Oh, I guess I didn't use that for anything.
Yeah, if you run back through that again and record those V caps, what you'll see is they obviously go up. They'll start off very low. They'll match roughly what you got in V cap, V Theo.
So that should be,
And
oh, that matches. Okay, that makes more sense then. Okay, and then for this graph, I went through and I changed it to be 1 over here and then 0.02. But these values are still,
okay,
they're like
that should
1
be
off or
1.
something.
That shouldn't be 1. It should be 1 times 10 to the negative 6th, unless, oh, it was in micro, so that should be right. And that's charge. That charge should be building up. And you are getting closer and closer, so that looks like that's doing right. A2 is what that is. You got 1 microfarad. Oh. No, it's the one in front of the multiplication symbol. That's not right.
Oh, this?
Yeah, the C is equal to Q over V. So if you take the, if you want the charge is going to be capacitance times the voltage. So you need 1 microfarad times 8 volts.
So this should
And
still be
you
an
have
8.
to actually make that basically to make it match. What numbers are you getting right now?
With the 1, I'm getting 0.13.
Okay.
Oops. So it should be 8, you said? 1 times 8?
Yeah. Yeah, that looks
That's
a lot better now.
closer. Oh, okay. Thank you so much.
No problem. Yeah,
I think I'm good with this one then. Then they would both be matched. I just have to fix these real quick.
Yep.
Okay. Thank you so much.
No problem. You're supposed to be in room number 1, 2,
4.
3, 4. Thank you. I'll send you back.
Thank you.